Alright, I'm going to walk you through some sample problems, and then you'll solve a few on your own as a review for your test tomorrow. Remember, if you said you were going to ask for help yesterday, you need to schedule help. Okay, first, we need to check and see if it's balanced. 1 ammonium. We don't have ammonium on this side, so we need to break it apart and count it as nitrogen. That's 2 nitrogen, 1 sulfate, 1 sulfate. Now, I don't have a hydroxide either, so I need to break it apart into hydrogens and oxygens. So let's count oxygens first. I have 2. And on the product side, I have 2. And then my hydrogens need to be treated as separate. 2 plus 8 makes 10. 4 plus 6 makes 10. So it's already balanced. Let's do a better job. There we go. Okay. So your first step, because this one is a mixture, I haven't told you if it's moles to moles or grams to moles or moles, molecules to molecules or anything. You need to determine. So look at what you start with. 13 moles. And we're going to how many moles? Mole to mole is a 1-step conversion. So we write down what we start with. 13.0 moles. Then calcium hydroxide is CaOH2. And then it's a 1-step equation. Moles of calcium hydroxide will go here in the denominator, and we're converting that to moles of ammonia. And ammonia is one of those formulas that you should remember. It's NH3. When you're doing mole to mole conversions, you use your balanced coefficients. The coefficient on calcium hydroxide is 1. The coefficient on ammonium is 2. Ammonia, my bad. Now we would multiply. Our answer comes out to be 26.0 moles ammonia. There you go, that's a full credit answer. There we go, we have the same equation. We already know it's balanced. In this case, we're starting off with moles of ammonium sulfate, and we're ending up at grams of water. Mole to gram is a 2-step equation. So we write down what we start with for 0.5 moles, and then ammonium sulfate is this one, NH4 2SO4. And that's a 2-step equation. So let's go ahead and fill in our 2 steps. We have to get from moles of one thing to grams of another, which means we have to compare mole ratios. So we have to go mole to mole, and here we use our coefficients. Then we can compare moles of water to grams of water. Because if we remember back out here on this line, the only way to compare grams of something to grams or molecules of something else is you have to go through this mole to mole conversion. So if you change substances, you're going to have to go mole to mole at some point. And then when we see grams, we're going to need to make our mass table. So we have hydrogen, oxygen, there's 2 hydrogen, 1 oxygen. Hydrogen has a mass of 1.01, oxygen is 16.0, for a total of 18.02 grams. We would pull out our calculator, and we end up with 18.02 times 9. hold on. That was a mistake. There we go. 162.18. Don't forget your unit, grams of water. I'm going to pull that out of the way a little bit. You guys go ahead and pause the video. Take a moment to work out letter C. You have 231.0 grams of calcium hydroxide reacting completely. How many moles of calcium sulfate form? So pause the video, and we'll see if you can get the right answer. Alright, so our answer comes out to be 3.12 moles calcium sulfate. The quick way to work through that, you write down what you started with. We're at grams of calcium hydroxide, so grams of calcium hydroxide goes in the denominator. We compare that to moles of calcium hydroxide, so moles of calcium hydroxide goes to the denominator in the next step. And then we can convert moles to moles, so at that point then we can compare to moles of calcium sulfate. All the ones cancel, grams cancels grams, moles cancels moles. What we're left with is moles of calcium sulfate, which is what our question's asking us for. Then we take 231 divided by 74.03, and that gives us 3.12 moles. And that's your reaction stoichiometry, real quick in a nutshell.